Hi everybody, good morning. That was the TryHackMe room was released yesterday. Breaking crypto the simple way. This is more an introduction, but also it has a couple of scripting. It's not simple. Yeah, it's not that difficult, but they give us the script. So most in this room is understanding the overall objective. For example, understanding why cryptography may stay secure, recognize and exploit vulnerability, learn how to identify and exploit the issue, and then understanding secure cryptography. This room is good because you might get a CTF, so you can, for example, save the keys that save the scripts that they give you, for example, in TryHackMe. So it's ready scripts. You can save them and use them for the future. This room is free, so everybody can use it, so you can read about it. I'm just doing it in case someone got stuck in labs or something. There's some rooms here, for example, no, this is a cryptography model. There's some introduction, you can go through it. Also, this one, this is the same things, cryptography model. This is cryptography 101. This is just 3. This one has 4. And then if you want to challenge, there's a room called breaking RSA, and it this is a nice room because um, you can experience some of the things that we talk about it in this room. Okay, let's start. First of all, they told us to add the hosts, so let's stop the noise. So we need to add the host because we need to do that. So if we go here, they tell us to bcts.tryhackme, bcts with my IP. Let me copy that. bcts.tryhackme. So if things go well, so there's bcts.tryhackme, and we have two labs we can use now. Now, if we add introduction dot one, so they say how to add. This is straightforward. You can add. We are not using Windows, we're using Linux machine. So the first one is brute forcing keys. So basically, now cryptography relies on premise that key used in cryptography are computationally infeasible to guess. So basically, an example is the 128. Let's see if we make this bigger. So 128-bit key has, of course, because it's a bit 2, so 2 power x to 128 possible combination, and this one is 2. Even with most modern computing power, this is will take too long. Strong keys, of course, the length is key. You have a longer key. Entropies mean randomness, and that's why it's not related to timestamp of data. That's mostly there's a proper random scripts. Sometimes they use even hardware for this. Uniqueness key must be unique across different because if you reuse the key you end up having an issue. We'll see another attack to do that. The famous one, of course, the RSA encryption, named after the investor Rivers, Shamir and Edelman. The whole point of RSA is the prime numbers. So they choose very big, large two prime numbers, and that's how start the encryption. And that's why I said this room is it's good. It used the weakness when I think if I remember very well this room that they're not very large. They're close to each other. So we have this, then you create n is the product of these two. So the whole point of RSA is, can you factorize a number n that is a multiply or two large prime numbers? So this is very difficult task in math to do that, and that's why RSA is strong. E is a small public exponent commonly. This is public. You can see, for example, if in this room they, and this one, for example, the factorize of a number, they call it Fermat factorization algorithm in Python. Now, the private key is derived from this function phi, where phi is a Latotian function, and we have a d, the modular inverse of e. So you don't need to confuse yourself too much with math if you're not famous with algebra and things like that. So the whole point of our set depend on difficulty of factoring n. So even if you found n, it's not that easy to find p and q, and that's what the whole story. Now I thought you give us an example, for example, of this script. It's you can run it on your computer. So let's try to run it. So we can just follow. Let's call it vmfactor.py. So here it basically check the time. If you have small, for example, number, how long it take the script, the factor in. If we give it a larger and more larger. So if I run the script, for example, Python Jaeger 3.9 factor, he said simpy is not installed, so pipe 3 install simpy. Let's see. I think he's going to Python 3 here. And you can see the time is, this is a 3.9, so it's increasing, even if the second, but it increase in time. So the prime number grow larger, the factorization time increase exponentially. That's the whole point of exponentially. So they don't increase slowly, making brute force factorization infeasible for properly generated RSA key. Now, here there is a paper talk about explore how poor randomness in RSA agent can lead to reverse severe vulnerability. This is if you're interested in mathematics and things like that, you can read this. Predictable prime. If P and Q are generated using weak randomness number generator, seed with system time, an attacker can recreate the key generated process. Shared, this is also a very dangerous one when you have a key used in different scenarios, and that's why we call it can use the greatest common divisor GCD method to factor n1 and n2. Basically, you have P. One of the key was used in two different scenarios, so you can break both keys. Small difference, as I said, this room I think it's used a small difference scenario. You can test that room if you finish this, and we're using ferment factorization method. This is the script for if you want to do CTF. This room basically, if I got some to explain it. So basically, if you have the same key used with different two cases, so you get GCD n1 and 2 equal for this, because PQ1 and PQ2, and then we have the P in this scenario. Then for the first key, but when we find P, because in this scenario, because you have n1 and 2, you get P, and this is a little bit mathematics if you're interested to read about it. So you get the first key 1, key 2, and then use that function to get calculate for each keys and break both keys. Basically, that's the scenario for these things if you want interested in mathematic things. Now we have an exercise. They give us a public key. The exponent usually is also public, then they give us the ciphertext, and here the key, if the whole point is using if we can factorize, even with this is not easy. That's why they said to us don't use the attack box for these scripts. I didn't try this one things. If you try this Python, it's long. I was before I start the room, it's still running. You can see it's still running my computer. I just cancel it. It's taking a long time for even to run this factorize this number. Now they give us best thing to do for this. We can just go to this site and we can have this there. And if we factor as they give us because this one is like you have a database, so it's easy to find these two numbers. So we'll find P and Q. That's our P and Q. So you can just go to my computer now. So we have P and Q there. So we have this time. Let's call it Vim. What's the task we're doing here? Um, Yeah, predictable prime, for example, this one is brute force in the keys. So let's say call vim brute.py. So let's before we start our script, we have this. We already got p and q. This is p equal, and then let's go there, remove this. This is a q. So you have p and q, and then they give us we have the n. This one we need the n, the public key. So pq, and we have n. So n is given. The p and q we got them from this, and then so we are not using this script because it takes long to get these things. So we're using this website to get p and q, and then we have using the 2' calculate phi. So we did the math of it, so we can go and having this. So after this we can calculate, we have p, we have q from this, then we print the function. We need this of course the head of the Python script, so this is interesting, so let's put that in the top. And then we have the E, we have the D, because the D is calculated. Let's so we calculate that. So let's go down. After he print us the N, the phi, we have then E, we calculate the D, the inverse, and then we have the cipher text, and then we get the flag at the end. Let's put that script on. So in theory this script should decrypt the flag, and we have the ciphertext C, we have the P, we have the Q, we have the N, we have that. So if we do that, so the whole point was this, because we've been able to find POQ, we've been able to find POQ from the N. So it means that the prime numbers are not that large. So if I do Python 3.9 brute, simply we can say pipe 3 install simpy. What else is no models? Oh, it's going to 3. This Python sometimes I hate. That's why I use a virtual environment whenever I use Python. So if you use Python 3, it works straightforward. There's something you talk. What is it that command? Or is the next one? Decryptor. I forgot which one they said supposed to answer one libraries. Yeah, this is that's one of the things. So you can, for example, that's one of the things when you do this walkthrough, save these scripts. So for example, these scripts, save them in your computer. When you get on your CTF, you have script ready. So this script, for example, you can save it. So it means if I'm in your CTF and the question is, we've been given the P and Q, and was able to, for example, to get P and Q and have all the data in on Cipher, so this script is easy and ready to get the description text like we did now. So for example, we found our flag, so you can put the flag there, so it's easy for you to start directly, so you don't need to um, avoid small public response, like, oh, of course E equals 3 is like straightforward. That's why they use large one. And show encrypted message are padding with random data PKS. So this one usually advanced cryptography to prevent mathematical attacks. Use different plain text for different recipe to avoid condition. Yeah, basically this I can imagine that in week time or something, TryHackMe will release a CTF or like related to this, and so you can put these scripts handy. So save them and prepare for the CTF next time when it starts. Now, breaking hashes. Now the hashes we know for password storage, data integrity, message HMAC, message authentication. Of course, if you did this room, you can know more about the hashes. Um, the hash, one of the things is that's why, for example, we talk about Sultan. You find also when you do the password database, input concept produce the same hash because that's what the hash is. It doesn't change when you have the same input. That's precompiled data. That's what we call rainbow tables. So that's why this Sultan added to that unique randomness value to each input before hashing prevent this. And secure HMAC, the hash function is insecure or key is short over the collusion, all of that relating to hashing. Now, for example, they talk about it, SHA-256 is not good for password hashing. It's fast, but it's not. And the key here is, if you read about it, especially this table, give you why. The MD5, you can make 10 billion hash per second, SHA 1 billion, and then bcrypt 1000. So if you are encrypting password in database, I think WordPress use bcrypt if not mistaken, and you can see this argon 2 ID is the best. It means even the hacker, if he got a password, for them to brute force this is take long time. So SHA is good, for example, for quick. That's why I give you now this table. Strong password are going to be bcrypt and this one. Data integrity because it needs a quick result. SHA, it's good. Message authentication, you don't want to wait too much for the email or things like that. So that's why different encryption, different scenario. Now they give us here the message. Can you guess my secret? And they give it SHA digest. That's now usually here we go into using hashcat because hashcat has the you can encrypt these things. So if we test, for example, this um, now computer the attack box, I don't think attack box will work. I did tried it last time, it didn't. So you do 150 is related to hashmark because if you're familiar with the hashcat, um, let's see if it run it. Let's see if it should work. If it doesn't run, I'll run it my computer. Let's see if it my computer found it quickly. Let's see if this one can find it quickly. Yeah, it's, if you're interested in crypto, you want to go deeper. But for these things, you make your notes. Like for example, like now, if he has a CTF or something related to HMAC and message, yeah, you know exactly the command you'll use. So you have that, so you can just. Did he find it? He found it. Yesterday he couldn't find it. I don't know why today he's found it. Yesterday the computer said hashcat in TryHackMe. You couldn't find this one. So we have that. So this one is straightforward because we already have a tool for it. So if we go to next, exposed keys. This will give us a lab in copied. We already have it, I think. Lab 1, exposed key. This, if I, so for example, I say test, it tell me submit. But if I go view page source, interesting part of this is that this function is JavaScript function that exactly uh, that's why you don't want to have encryption key inside your source code. Like here we already have the key, which is that it's an easy key, and then generate random 16 for the IV, then send it to the server, and if I go view inspect, what is a freezing now? If I go to network and just submit that one again, what's going on now? If I submit again, you can see it's a post request to endpoint endpoint process.php, and if I see request here is data, so basically is encrypted, and you can see the IV, and then of course a response message test invalid. So here we are not really testing how to do, because TryHackMe already give us okay, so you can see what same we've been doing now. For easy, they give us a quick new word list to use, so we'll have this word list. The idea is, of course, to save time. One of the answer is in this word list, so you can just do we did that. Let's see what we have here. We can do wget. Let's get the list first. So we have the word list here, so this is part of the word list. How many data we have there? We have 150. So if you stuck, just copy and paste and then you find the correct one. So we have that, and then they give us the script. The script is, that's why I said one good thing is to save these scripts and use them in the future. So for example, now this one is brute forcing, for example here, as we said, the exposed keys. So if we go there, for example now, control V, vim exposed.py, and then we have the script. Of course, the endpoint, as we said, we know it's a process PHP. We got this from, because we have from the room itself. So basically it's like reverse engineering. Now with AI, Gemini, Claude, all of this, you can just, if you can copy this to them, they will give you the script to reverse it. So basically encrypt the message, send it and test it, and at the end, if you get it correct, it will tell us the um, now here Kim's trying to explain it. I think they explain it nicely here. View explanation. We have the URL. They said we have the process, the endpoint where the JavaScript send the file, the encryption. We have the encryption key. So encryption is given message ISCBC mode, padding message, encrypt the padding, send a payload with IV, brute force because we have the word list. And okay, so let's try use Python 3 as a suggestion, because we don't have some libraries. Let's see if Python 3 can get it straight without problem. Oh, that one. So we need to add pipe 3, install, I forgot the name. The name, they tell us the name to install here. This one. If you are in the attack box, use this, install this Pycrodon. So if you install that one, depend of your computer, I'm not sure what you guys using, so if you run all that, now you find it quick, because it's only 150. Remember the word list we have now, it's only 150 line, so it's 150. You can see in the, so it's not too long too. That's why you found the thing. So the message is this. So my computer is freezing or, so if we go now, and then we got the flag, so we have the message. So let's copy it before freezing on us. So basically this one is the idea here. Do not have your key hard coded in your code. Bit flipping always, you know, for example, to explain it, let's get straight to this. So let's go back to bit flipping there. So they tell us, for example, this testing. So TryHackMe, the lab, they make anything. You can just put anything for testing, because it doesn't. So it tell us we are guest. So if you go to storage, I don't know, my internet is freezing or something. If you go to storage, hello, you can see storage. We have why is not we have authentication token. We have, this is the PHP one, and we have the role. The role is this. So we can see the random number. Of course, now for example, if you know from the key, so it starts with role 0 and the token, and then the token 2. The role is token 2 role and key and IV, so it's encrypted and put role equals 0. And then we have basically this scenario. So if we can flip 0 to 1, uh, and there is because it's a cipher block chaining, the plaintext XORed with the previous ciphertext block before encryption. So if the attacker alters bit in the ciphertext block, it changes the corresponding plaintext block during decryption. So this is part of the attack, bit flipping attack. Is we know some many CTFs they use it. So, and then of course we have the script that do the good things. You save the script, and when it comes time for CTF or something, you can use it. So if you're interested in more about instead how the encryption work, you can learn it. Otherwise, you can just instance. So for example, here I have the original token. We give it to the script. Hex, because you convert to hex, then start the block size and do all that, and then the offset gets 0 and start doing the flip the bit from 0 to 1, applying the bit flip, and then yeah, as I said, sometimes either you learn how to use the scripts, or you want to get deeper and stand in the script themselves. So if we take this script, for example, this script that they gave us already, and then let's take it to our room, and then where is that thing? So if I go now there, so if I said flip .py, we don't need to change anything in the script. It's like a network is a phrase. So already there's this block size 16. The token is, we give it by input, we're not hard coding it. So yeah, basically the script will do the whole work for us. Something is not right. The machine is freezing. I'm not running anything, so why is it freezing? Hello. TryHackMe, what's wrong with you? So basically, we only give it our key, our the encryption. No, it's TryHackMe is playing games with us. I don't want to redo this video. Please, please come. Don't do this. I have internet, so my internet work fine. So why is this failed? So what? I need to restart the machine now. Uh, Is the attack box, I think, the messing up with me. Hey, sometimes TryHackMe start freezing this couple of months. I'm not sure what's going on their side. Yeah, same things. This. Let me start the attack box quickly again. I don't know why they keep doing. Sometimes it's just. Okay, guys. Okay, let's see what else we do. Basically, if you run now that script, you get your. So not. We need to redo the whole things now. bcts.tryhackme. I hope it's. Guys, let me pause it quickly before you guys. Hi guys, I'm back. I restarted the machine. So as we said, we are on the last task. Let's try before it freeze again. There is a freezing in this machine for whatever reason. So if you log in, of course, we said you go to inspect. You go to your storage, and you can see your cookie, and we talk about this part. So our interested in this role, and we said we can copy this one. Remember, we're using this script that will flip the byte for us from 0 to 1. I copy the script, and you can see the freezing in TryHackMe server for whatever reason. So Python 3, let's do it flip, um, and we can put our code. Now origin IV, we got it. Remember to remind the reason no, this one is the flip one, is not the JavaScript one. Use this token. So we have the new token. If I copy this new token, hold on a minute before it freeze again. Yeah, this is good script. I said I can come to my role here. I can just remove that one. I can paste this one there, and then you can just refresh the page, and you got you flip, and you are admin. So this is a nice script. I would save all of them, guys. You should do the same in case you have a CTF. You don't need to waste time for googling. So you have a ready script for flipping. Understand how it works, so you know how to use it in the future. You have this script, the bit flipping, of course. That's one of the things at the end. And we got bit flipping, and then you have the nice script also, exposed key. This one is we did the one when you have JavaScript. So if you have understand this one how it work in future CTF, you can change this script to use it to do also the same job. And then we have also breaking hashes. This one is straightforward because we're using hashcat. You just need to remember it's the mode 150. What else we got? Brute forcing the keys when they are not large enough. So we have in this one, the good things they give us, for example, if you are in CTF, you have two tools here. You can try them and or use this one because it's in the database for quite large numbers. The conclusion, of course, is brute forcing recap the key concept, brute forcing key, weak or predictable keys, breaking hashes, we MD5 and SHA and all of that. Key exposed in class-sign code, don't hard code encryption key or API16 front code, that's not supposed to do. Bit flipping, and authentication encryption, IICBS MAC. Best practice, of course, use strong keys and secure algorithm, entropy and all of that. Avoid exposing key in client-side code. Implement authenticated encryption. Always pair encryption with integrity check. secure ASA, so you use large number, educate developer, and all of that. The room, as I said, is free, so you can read about it on practice. So you can do that. So let's close, and we're done. And we froze again. So yeah, so that's this the room. I hope you like it, guys. If you have question, let me know, and please like and subscribe, supporting. Thank you very much, and have a good day.